Now we are going to see flip-flop. Flip-flop is a sequential circuit. Its present output is depends on present input and past output. Flip-flop is a bistable digital logic circuit, means it has a two stable states, logic 1 and logic 0. This is block diagram of flip-flop. It has one or more inputs and two outputs. Two outputs of flip-flop are always complements of each other. Flip-flop requires clock signal to be applied at its inputs for operation. Means flip-flop operates only when clock signal is connected at its inputs. Depending on the clock signal conditions, flip-flops are triggered in four ways. Clock signal is nothing but square wave. Now, depending on clock signal condition, there are four triggering methods which are positive edge triggered. First is positive edge triggered. When positive edge of clock signal is appear at the input of flip-flop, then flip-flop update its output. So that flip-flop is called as a positive edge triggered, because at the positive edge of clock signal it updates its outputs. Now second is negative edge triggered. When negative edge of clock appears at the input of flip-flop, flip-flop update its outputs. So it is called as a negative edge triggered flip-flop. High level triggered. When high level of clock pulse appears at the input of flip-flop, it updates its output, so it is called as a high level triggered flip-flop. Fourth is low level triggered. When low level of clock signal appears at the input of flip-flop, it updates its output, so it is called as a low level triggered flip-flop. Now outputs. The output states of flip-flop are updated according to the inputs of flip-flop only when clock input is activated. The value of output states at any given instant of time is called as a present states of flip-flop, and that present states are denoted by Qn and Qn bar. Now, upon activation of clock input, the new output states of flip-flop is called as a next state, and it is denoted by Qn plus 1 and its complements Qn plus 1 bar. Now there are four flip-flops: SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. These flip-flops can be implemented by using universal gates. Now this is a diagram for SR flip-flop using NAND gates. Now there are four NAND gates used to build a SR flip-flop. There are two inputs S and R and one clock input. Clock input is nothing but square wave. S means set, means logic 1. R means reset, that is logic 0. Now this is a positive edge triggered flip-flop. So clock input can be considered as a 1. When clock input is 1, flip-flop operates and it updates its output. Now first and second NAND gate are cross coupled, means output of first NAND gate is given as input of second NAND gate. Output of second NAND gate is given to the input of first NAND gate. Now there are two inputs S and R. Now there will be four combinations for inputs. We will see these outputs of flip-flop for every combination. Okay, first combination is S equal to 0, R equal to 0. We will see next state for this flip-flop when S equal to 0, R equal to 0 and present state, that is Qn equal to 0. Now here S equal to 0, R equal to 0 and Qn equal to 0. Now to operate this flip-flop, clock signal should be 1 because it is positive edge triggered. Now when one of the input to the NAND gate is 0, it produces output 1. So here one input is 0, it produces output 1. Here one input is 0, it produces output 1. Now Q1 present state is 0, so 0 is connected here. So 1 0 NAND 2 gives output as a 1, which is nothing but next state. and next state here is qn plus 1 bar equal to 1. This 1 is given as the input to this first NAND gate. So 1 1 produces output of this NAND gate as a 0 0, that is next state of this case. So qn plus 1 becomes 0. Now draw the truth table for different cases. Now clock pulse is applied here, s equal to 0, r equal to 0, present state qn equal to 0, and now next state we get next state as a 0. Now we will see for next case, that is s equal to 0, r equal to 0, and present state qn equal to 1. Now from this diagram, s0, r0, clock 1 and qn equal to 1. Now one input for NAND gate is 0, so it produces one output. R equal to 0, it produces one output. Now qn equal to 1, it is connected to the second NAND gate. So 1 1 produces output 0, which is nothing but next state qn plus 1 bar. So it becomes 0. Now this 0 is connected to the input of first NAND gate. So 1 0 produces output as 1, which is nothing but next state. Now this qn plus 1 equal to 1, qn plus 1 bar equal to 0, which are complements of each other. So this is a valid state. So for this combination, output is or next state is 1, which is written here. So from these two cases, for s equal to 0, r equal to 0, next state is same as present state, means there is no change. So that state is called as a no change state. Means for this case, when s equal to 0 and r equal to 0, flip-flop acts as a memory element, because next state is same as present state. So this can act as a memory. For this case, flip-flop act as a memory. Now second case is when s equal to 0, r equal to 1 and present state is 0. S equal to 0, r equal to 1, present state is 0 and clock is 1. Now one input is 0, it produces output 1. Here clock 1, r1, it produces output 0. Now here one input is 0, so it produces output 1, which is nothing but next state qn plus 1 bar equal to 1. This 1 is connected to the first NAND gate. So 1 1 produces output 0, which is nothing but qn plus 1 equal to 0, which is next state. Now this qn plus 1 and qn plus 1 bar are complements of each other, so valid case, so can be written. So we can update a truth table for 0 1 and qn present state 0, next state is 0. Now next case, when s equal to 0, r equal to 1 and qn equal to 1, means present state equal to 1. So one input 0, it produces output 1. Here fourth NAND gate gives output as a 0. One input is 0, so it produces output 1, which is nothing but complement of next state, that is qn plus 1 bar equal to 1. This 1 is given as a input to this first NAND gate, so 1 1 produces output as 0, which is nothing but next state. Now these two are complements of each other, so this is valid case. We can update truth table. So for this case 0 1 1, next state is 0. So by observing these two rows, we can say that when s equal to 0 and r equal to 1, output or next state is 0 0, which is nothing but reset state, means output is 0, so reset state. Now next case is when s equal to 1, r equal to 0, qn equal to 0. S1, R0, Qn 0 and clock 1. Now one input of the NAND gate is 0, it produces output 1. Now 1 1 produces output 0. Now one input to this first NAND gate is 0, so it produces output 1, which is nothing but next state. Now this next state output qn plus 1 equal to 1 is given to the input of second NAND gate. So 1 1 produces output 0, which is nothing but qn plus 1 bar. So Qn plus 1 bar equal to 0. So these 1 0 complements of each other. Now update truth table for s equal to 1, q r equal to 0, q equal to 0. So Qn plus 1 1. Now next case, s equal to 1, r equal to 0, Qn equal to 1. So s equal to 1, r equal to 0, Qn equal to 1. Now 0 produces output 1 and 1 1 produces output 0. 1 input to the NAND gate is 0, so it produces output 1, that is nothing but next state Qn plus 1 equal to 1. Now this is given to NAND gate, so 1 1 produces output 0, which is nothing but Qn plus 1 bar. So update truth table according to that. So 1 0 Qn equal to 1 produces output 1. From these two rows we can say that this state is set state, because output or next state are, for both cases, for Qn equal to 0 and for Qn equal to 1, it produces next state as a 1. So this is a set state. Now next state, when s equal to 1, r equal to 1. When s equal to 1, r equal to 1, Qn equal to 0. 1 1 Qn equal to 0, clock pulse 1. Now 1 1 produces output 0, 1 1 produces output 0. So 1 input to this NAND gate is 0, so it produces output as 1, which is nothing but next state Qn plus 1 equal to 1. Now 1 input to the NAND gate is 0, so it produces output as a 1, which is nothing but Qn plus 1 bar equal to 1. Now both Qn plus 1 and Qn plus 1 bar trying to become 1, which is not valid, because complement should be, if 0 is there, 1 should be here, but here both are trying to become 1, which is not valid. Now update truth table according to this. For 1, s equal to 1, r equal to 1, Qn plus 1 equal to 1. For s equal to 1, r equal to 1 and Qn 0, Qn plus 1 equal to 1. Now last case, when s equal to 1, r equal to 1 and Qn equal to 1. Now 1 1 produces output 0, 1 1 produces output 0. Now, because of 0, output is 1, which is nothing but Qn plus 1 equal to 1, Qn plus 1 bar equal to 1. This also update truth table according to that. So 1 1 1 produces output 1. Now in this, for these two rays, Qn plus 1 and Qn plus 1 bar both trying to become 1, which is not valid. So this case can be called as a invalid case or invalid state. Now these 8 conditions are when clock pulse is applied. When clock pulse is applied, flip-flop updates its output. When clock pulse is 0, when clock pulse is 0 means clock pulse is not applied. So for any value of s and r, for any case of s and r, output will be same as input. No, sorry, next state is same as present state. Means we can say that there is a no change state. So for when s r are equal, means when s r equal to 0 or s equal to r equal to 1, when s equal to r equal to 0, flip-flop can operate as a memory element, and when clock pulse is not applied, flip-flop also can be used as a memory element. So this is a truth table for SR flip-flop.